the James Webb Space Telescope, humanity's most advanced eye into the cosmos, has shattered every expectation since its launch, becoming the greatest deep space detective in the history of science. Designed to look deeper into space and further back in time than any telescope before it, JWST isn't just another NASA project, it's a time machine, a truth revealer, and a silence breaker in the dark theater of the universe. From the moment its golden honeycomb mirrors unfolded and aligned to perfection over 1 million miles away from Earth, Webb began transmitting data that rewrote what we thought we knew about the birth of stars, the formation of galaxies, and even the conditions for life itself. One of its first groundbreaking discoveries was the detection of galaxies so ancient, so massive, and so luminous that they shouldn't even exist according to current models of cosmology, galaxies forming just 200 million years after the Big Bang, which has forced astrophysicists to reconsider everything about early universe physics and the speed of structure formation. Scientists expected to see faint blobs. What they got were massive spiral galaxies and complex structures that defy the timeline of the standard model. Then came its stunning revelations about exoplanets, planets orbiting distant stars. Using its ultra-sensitive infrared instruments, JWST, identified and analyzed the atmospheric compositions of multiple exoplanets, including the presence of water, vapor, carbon dioxide, methane, and even possible hints of dimethyl sulfide, a molecule associated with biological activity on Earth.
Ow.
Raising goosebumps across the scientific community and whispering the possibility of extraterrestrial life. The telescope's detailed spectroscopic analysis of WST-9b, a hot Saturn-like exoplanet, revealed a complex atmosphere filled with unexpected chemical fingerprints, showing for the first time how starlight interacts with alien atmospheres in ways we never imagined. In another jaw-dropping moment, Webb peered deep into the Orion Nebula and unveiled never-before-seen details of stellar nurseries, catching newborn stars and planetary disks forming in real time, something no previous telescope could observe with such clarity. The iconic pillars of creation were revealed in stunning, layered detail, stripping away the obscuring gas clouds to reveal the hidden activity inside, as if the cosmos itself was finally unmasked. But perhaps the most spine-tingling discovery came when Webb detected the light from the earliest quasars' ultra-bright galactic cores, powered by supermassive black holes that somehow already existed in the first few 100 million years after the Big Bang. This discovery has left scientists stunned, as it suggests black holes grew far faster and earlier than any current theory predicts, pushing us toward new physics and deeper cosmic mysteries. JWST also provided the clearest views yet of Jupiter and its turbulent atmosphere, with infrared imaging capturing auroras, giant storms, and ring systems in exquisite detail, making even our familiar solar system feel newly mysterious. Its images of Titan, Saturn's largest moon, revealed complex weather systems, methane clouds, and surface patterns hinting at active geology and perhaps subterranean oceans, raising once again the haunting possibility of microbial life beyond Earth. When Webb turned its gaze towards Stephan's quintet, a group of colliding galaxies, it gave humanity a visual symphony of cosmic chaos spirals merging, black holes feeding gas clouds, warping, helping us better understand galactic evolution and our own Milky Way's distant future. Then came its most humbling task, refining our measurement of the universe's expansion rate. Webb's precision data has both confirmed and confused existing models, contributing to the growing Hubble tension, a conflict in the measurements of how fast the universe is expanding, which could point to entirely new physics or undiscovered dark energy phenomena. It's as if the universe, when seen through Webb's mirror eyes, is screaming that we've been wrong, or at least incomplete, in our understanding of its laws. Beyond these major discoveries, the telescope is constantly feeding us new wonders. Distant supernova lighting up like cosmic firecrackers, gravitational lensing that magnifies background galaxies using massive foreground clusters and interstellar chemistry. That hints at the molecules necessary for life forming in unexpected places. It's uncovering carbon-based molecules in deep space clouds, tracking star formation in faraway galaxies, and mapping the dance of dark matter through its gravitational fingerprints, all at resolutions so sharp they feel more like divine visions than science. And perhaps most poetic of all is the psychological effect, the humbling awe JWST provokes. With every image it sends back, we are reminded how small we are, and yet how brilliant our minds must be to have built a tool that lets us stare into the birth of time itself. The golden mirror of the James Webb Telescope JWST just reflects starlight tit, reflects our species' hunger for truth, our curiosity that knows no ceiling, and our willingness to ask questions we may never fully answer. It's a machine of miracles, a whisperer of cosmic secrets, and with every day that passes, it edges us closer to the ultimate mysteries of existence, where we came from, what's out there, and whether or not we are truly alone. The James Webb Space Telescope has only just begun its mission, and yet it has already cracked the sky open wider than ever before. And if these are its first steps, then the future of cosmic exploration may well be stranger, wilder, and more uninspiring than anything science fiction ever dared to imagine.